All right, for section 4.2, we are working on making equations from tables. So the first example we're going to work on has to do with these four shapes. It asks you for the number of the shape and the perimeter and to find some kind of relationship. So this is not on your homework, but this is just a good example that you will see later on your quiz. So for the number of shapes, we have shape 1, 2, 3, and 4. So we're going to go ahead and put those in. And then for shape 1, how many are in the perimeter? It's 6 plus 1 plus 6 plus 1, which gives us 14. And then for shape 2, we have a 6 on this side, so we have 6 here, and we have 1 on top, 1 on the bottom. Same thing, so 6 plus 6 is 12, 13, 14, 15, 16. We continue on the next shape, add a 6 there. We have a 1, a 1, a 1. And again, we're just going around the outside. That's what perimeter is. 6 and 6, 12, 13, 14, 15, 16, 17, 18. And then our final shape is 4 rectangles. And we have 12 plus 4 plus 4. So 13, 14, 15, 16, 17, 18, 19, 20. So hopefully what you notice is that each time we do a new shape, our perimeter is increasing by 2 each time. And that's all we would want to write on this one, is that the perimeter increases by 2. For each shape. Sorry, there's thunder out there. My dog hates it. It's right, bud. All right, so the next one we're going to do is, this is more like homework. You're going to get tables. So we learned yesterday how to figure out if it's linear or nonlinear. So all you're going to do is, let's start with our change in y. So our change in y, we see that this is going down by 0.5. And you could just put this in a calculator to show this. So every time, so to go from 1 to a half, it's subtracting 0.5. To go from a half to 0, subtracting 0.5. So all of these are the same. Then we need to do our other side. So this side over here looks like it's increasing by 1. Each time it's getting bigger. So remember, -2 plus 1, you subtract and keep the sign of the bigger is -1. -1 plus 1, 0. 0 plus 1 is 1. 1 plus 1 is 2. So in order to find the slope, we're going to take the change in y over the change in x. So that triangle means change. This number over here is your change in y number. Over here is your change in x number. So basically you're going to do -0.5 divided by 1. And it's like this for every problem. -0.5 divided by 1. So you get -0.5. The y-intercept is where your graph, it's the number for y when x is 0. So the number for y when x is 0. So if I look on my chart right here, when x is 0, y is 0. So my y-intercept will be 0. And then when you plug everything into your formula, the formula is y equals mx plus b. M is going to be your slope. So what we did up here, this number simplified, this is your slope. B is going to be your y-intercept. So our 0. So you're going to do y equals -0.5 x plus 0, but we don't write the plus 0. So we're just going to write y equals -0.5 x. And we don't put the plus 0. So that one's finished. Let's try another one. Same type of problems. So we want to find the change in y over the change in x. So we're going to label everything. So we have change in y. We have going down by 10. Every time it's decreasing by 10 on that right side. On the left side, same as before, increasing by 1 each time. And so your slope, again, change in y. That's a triangle. Change in x. This over here is your change in y number, and it's all the same, so we know it's linear. Over here is your change in x number. You're just going to do the one over the other, so -10 over 1, which is just -10. Y-intercept is where your x is 0. So find 0, and that number for the y, okay, is going to be your y-intercept, so 60. And then we just plug it into y equals mx plus b. So again, the slope is your m, the y-intercept is your b. So it's going to be y equals, just make sure you put the x, negative 10x plus 60. And that's your linear equation. So let's try another one. So this time our graph is going up by 6. So I'm going increasing by 6, increasing by 6. It's all right as long as the number stays the same. And then the other side is increasing by 2. So this is the first time where it was not increasing by 1. And again, that's fine as long as these are the same on the left and these are the same on the right, it's totally fine. So that's your change in y. Here's your change in x. So again, slope is change in y over change in x. So that'd be 6 over 2 and then just reduce it. So that's going to be a nice 3. Your y-intercept again is where your x is equal to 0. So that looks like 2. And then you plug it in. So y equals 3x plus 2. Now sometimes what will happen on our next example is you won't have a 0, so we're going to have to work backwards to figure it out. So first off, let's go ahead and do our change in y. So this looks like increasing by 5, so you're adding 5 to each side. And again, it's all the same, so we know it's linear. If those weren't the same, then we would know that they're not linear. The other side, increasing by 1. So my slope is change in y over change in x. So again, this is my change in y number. Here's my change in x number, 5 over 1. So 5 over 1 reduces to 5. Y-intercept, we have no 0. So what you want to do is think about what if you started 1 before this. So if we went back 1, we'd be at 0. So I know that I added 5 to some number here and it gave me 5. So think about what number could you add 5 to that you would end up with a 5, and that number is 0. Okay, so again, I'm going back. So it's almost like you're doing 5 minus 5 to get to the one previous. So our y-intercept is going to be 0. So our equation is y equals 5x, and we don't write the plus 0, so please try not to write the plus 0. And then our last example, change in y over change in x. So I notice that my value is increasing on the right by 5. So increasing by 5. And then my left side is increasing by 3. So when I do my change in y over change in x this time, I can't reduce 5 over 3, and that's okay. Leave it as an improper fraction, just don't make it a decimal. Slopes can never be decimal, so just leave it as a fraction. And then we're going to have to retrace our steps again to try to find the y-intercept because we can't see it as of the moment. So again, think about doing the opposite. So if you took this negative 2 and you did 2 and you subtracted 5, that would put you at negative 3. That's going to be this position here. If I go back and I do 3 minus 3, that's going to put me at 0. So that's where I need to be. So 0, negative 3. So negative 3 is my y-intercept. So my equation is y equals 5/3 x minus 3. All right, so do the best you can. Follow the notes when you're doing homework, and good luck.